use third-party codes to enhance your apps? What if there was a way to increase privacy and security for apps, SDKs, and users, benefiting the entire Android ecosystem? Hi, I'm Zoe, and I'm a Developer Relations Engineer on the Privacy Sandbox team. In this video, we'll look at the architecture and paradigm changes brought to you by the SDK Runtime. The SDK Runtime is designed to safeguard user data and enhance SDK and app security through third-party code isolation. What does this mean, technically, for you? Let's start with the architecture. Without the SDK Runtime, third-party SDKs are executed inside the app's process, sharing resources. The SDK Runtime introduces a separate runtime process in which third parties can run inside their own sandbox. You heard that right. It's like app sandboxing, but for third-party code. Just a note here, we say third-party code to simplify, but if you have an app, you could choose to encapsulate some of your logic and execute it within this SDK Runtime process. Each app has its own SDK Runtime. This isolates the code and resources from each party. During the migration stages, SDK developers can choose to rely on a translation interface to make the transition easier for apps or games. You can develop for the SDK Runtime from Android 13 and higher, but Android Jetpack provides backward compatibility support. Before we take a closer look at the specific changes, let's get acquainted with the terminology. A Runtime-enabled SDK, or RESDK, is an SDK that runs inside the SDK Runtime. In contrast, when an SDK runs inside the app process but interacts with a Runtime-enabled SDK, we call it a Runtime-aware SDK, or Array for short. An example of this is the translation interfaces that SDK developers can use to help apps migrate to their Runtime-enabled SDKs. Another important part is the shim generation tooling. This set of Jetpack libraries helps you abstract low-level IPC complexity. Finally, we have the Android SDK Bundle, or ASB, which is the format that enables distributing SDKs in a standalone manner. You can think of it like an Android App Bundle, AAB, but for SDKs. Okay, now let's take a closer look at the SDK Runtime changes. As a separate process, the SDK Runtime has its own well-defined set of permissions instead of inheriting the ones from the app. The set of permissions in the SDK Runtime is also immutable. Also, communications from the SDK Runtime are restricted. SDKs inside of it can only communicate with their client application and with other SDKs within the same runtime. This means that communications are limited, as well as certain types of intents or services. SDKs in the runtime cannot define components like activity or service in their manifest either. There are also changes when it comes to memory and storage. RESDKs have dedicated per SDK memory and storage space within the runtime, which is also isolated from the app. Considering all those restrictions, how does the app, or the Array SDK, communicate with the SDK Runtime? It can be tricky to handle low-level inter-process communication. To minimize the impact on app and SDK developers, the SDK Runtime introduces new entities to assist with this. The SDK Manager, which is used from the app's process, and the SDK Controller, which is used within the runtime. While these are designed to help you load and communicate with RESDKs, they still operate with binders. This means that the app and the SDK still need one more layer of abstraction, which is handled by the shim generation libraries available in Jetpack. The last significant change brought by the SDK Runtime is distribution. In today's paradigm, app developers package SDKs with their own code. This package is uploaded to a store and then distributed as a whole. It can also be used to generate an APK that is uploaded to a different distribution channel. That being said, this is a simplification. As SDKs become separate entities, they no longer need to be packaged together with their apps before being uploaded to a distribution channel. Instead, SDK developers can upload their version SDKs separate from the apps themselves. They can also choose to generate the SDK APKs using existing tooling like Bundle Tool. This is also available as a command line tool. SDK installation will be transparent for the user, just like today. Each distribution channel will ensure apps have the necessary SDKs. Explore the SDK Runtime to see how it can help you support a more private mobile future. To get started, visit the Privacy Sandbox developer site. You'll find code samples, the SDK development guide, latest announcements, technical documentation, and channels for feedback. Thanks for watching! We'll be exploring the SDK Runtime in detail throughout this video series. Be sure to watch the other episodes to learn more about how to build, consume, and test SDKs in the runtime.